Alright, today we're going to go over your functions unit test review so you can study and check your answers. So looking at the first four questions, we're going to look at the characteristic of each graph. Remember, you can choose between discrete and continuous, linear and nonlinear, increasing, decreasing, both, and neither. For each of these four questions, you're going to have three characteristics for each graph. Remember that discrete means that the graph does not have a line, continuous means that there is a line, linear means that there's one straight line. Non-linear means that it's not a straight line. Increasing means that the graph is going up. Decreasing means that the graph is going down. Both increasing and decreasing means that the graph is going up and down. And neither increasing or decreasing means that the graph's not going up or down. So looking at the first question, my graph does not have a line, so it's going to be discrete. These points are lined up in a straight line, and even though there's not a line connecting them, it's still linear. And as I take my pen to go from left to right, my dots are going up, so this will be increasing. On number 2, we do have a line, so it's going to be continuous. There is a straight line, so it's going to be linear. And as I take my pen from left to right, the graph is going up, so it will be increasing. On number 3, our graph has a line, so it's going to be continuous. It's clearly a circle, so it's going to be nonlinear. And as I take my pen from left to right, if I hold my pen right here, the graph goes up here and it goes down at the bottom. But if I slide my line over a little bit more, it goes down and then up. So this is going to be both increasing and decreasing. On number 4, we have a U-shaped, and there's a line, so it'll be continuous. Again, it's a U-shape, so it's going to be non-linear. And as I go from left to right, the graph starts to go down, and then it starts to go up, so it's going to be both increasing and decreasing. Alright, remember on number 5 and 6, we are determining if graphs are functions or not. So we're going to use our vertical line test. So we're going to take our pen or our pencil and go from left to right. And if you hold your pen in one spot and the graph touches more than one on the same vertical line, it's not going to be a function. But if it only touches once, like this one does, this only touches one everywhere I slide my pencil. So this one is going to be a function. But if you look at number 6, if I hold my vertical line up, it touches in 2 spots everywhere on the drawn graph, which is a circle. So this is going to be not a function. For 7 and 8, we're determining if sequences are functions or not. And remember that all sequences are functions. Remember that you can't repeat. You can't have 2 first terms, 2 second terms, 2 fourth terms, or 2 fifth terms, or you can't have 3 third terms or anything like that. So since that's the case, all sequences are functions. 9 and 10, you're looking to see if the tables are functions. Remember, you just need to see if anything repeats on the x side. If something repeats, it's not going to be a function. But not everybody can see it in the table as good. I prefer to map it out. So we're going to write down our inputs, which are -2, 2, 0. We do not have to write 2 down more than once. Okay? Then we have y. We have -7, 5, 16, 0, and 6. And we're going to match up and draw arrows. So -2 and 7, so we're going to draw an arrow. 2 goes to 5, 0 and -16. 2 goes to 0, and 2 goes to 6. You can have one button give you 1 soda. You cannot have one button give you 3 types of soda. Since one button can't give you 3 types of soda, this is not a function. Alright, same thing on number 10. We're going to map it out. We're going to write down my x's or my inputs. -5, -3, -1, 1, and 3 are my inputs. And my outputs are 8. Again, we don't have to repeat that since we've already written it down. 8, -2, and 11. Negative 5 went to 8. Negative 3 also went to 8. Negative 1 went to negative 2. 1 went to negative 2. And 3 went to 11. We need to ask ourselves, can 2 buttons give me 1 soda? The answer is yes. 2 buttons can give you 1 soda, and 1 button can give you 1 soda. So this is going to be a function. Going to the next page of our review. Right, we're determining if these equations are functions or not. So we need to make a table and choose values for x. So let's say I choose negative 5, 0, 5, and 2. Again, it does not matter what values you choose. We're going to plug it in here. 5 times negative 5 is negative 25, plus 3 is negative 21. 5 times 0 is 0, plus 3 is 3. 5 times 5 is 25, plus 3 is 28. 5 times 2 is 10, plus 3 is 13. Then we're going to map it out. We have negative 5, 0, 5, and 2. We have negative 21, 3, 28, and 13. Each one had its own output, so it's going to be a function. We'll do the same thing for number 12. Let's say I choose negative 2, 0, and 2. We're plugging that in. Negative 2 squared is 4, because negative 2 times negative 2 is positive 4. 0 squared is 0, and 2 squared is 2 times 2 is 4. Again, we're going to map that out. Negative 2 goes to 4, 0 goes to 0, and 2 goes to 4. 2 buttons can give you 1 soda, so this will be a function. Number 13, we are determining which ordered pair is a function. So we need to look and see. You can either map these each out, or you can just look at your x values and see which one repeats. So we have a 2, a negative 3, a 2, and a negative 2. Since I have 2 repeated in the x, it says which of the following is a function. So A can't be it. So we're looking for something that does not have a repeating x value. 5, negative 4, negative 5, 4. We have a positive 5, negative 4, negative 5, positive 4. So nothing repeats here, so this one has to be a function. We have 8, negative 5, negative 5, negative 8. Since I have 2 negative 5s in the x portion of your ordered pair, this one can't be a function. Looking at D, we have negative 7, 6, negative 7, 10. Since I have 2 negative 7s in the x coordinate, that one can also not be a function. Again, you can map each of these out if you want to, or you can just look and see if the x repeats or not. If you have a hard time looking at this and seeing if it's a function or not, again, map it out. Alright, number 14 wants to know the domain and the range. Remember, the domain is your x values and your range is your y values. When you have an ordered pair, it's x comma y. So what I like to do is put x and y under everything. So my domain is 3, 2, negative 1, negative 6. My y values are 2, negative 3, 4, and negative 5. Number 15, express the relation shown in the graph as a set of ordered pairs. So remember, an ordered pair is x comma y. So this first point, we skip 4 lines and go over 2, so it's counting by half. So we go over 1, up 0, so we need to have a 1 comma 0, which we have here. We have a 2 comma 2. We have a 3 comma 4. and we have a 4, 5, so our answer will be A. Looking at number 16, we need to look and see if there's any repeating x's. We have -4, -3, -2, -1, 0, and 1, so it's a function. Our domain is -4, -3, -2, -1, 0, and 1 because those are our x values. Our range is 27, 13, 3, -3, -5, and -3 because those are our y values. For number 17, we have 2 buttons give you the same product. 1 button give you 2 products, so this makes it not a function. The domain is 10, 11, 12, and 13. Your range is 1,000, 2,000, and 3,000. You do not need to worry about 19 and the last one, which is 20. The last one, circle the graph that best represents the following story. First Coast Pool Services has just arrived to make a repair in the side of an underground pool. The pool starts at a height of 7 feet, so we need to look at one that starts at 7, which would be this one. It's drained by 2 feet, so it goes down to 5. The water is drained in 4 hours. Then 5 more feet of water is drained, which will take you to 0. It's the 5 feet is drained in 2 hours. The pool is left empty for 6 hours, and it is filled back up. So this one will be our answer.